Okay. Well, I think being equal, since it's the same error in my office, I'll put this back on if someone shows up. So this way you get the ambience of the regular classroom. This theoretically should work. I got record on, I didn't try recording with the classroom computer before, so hopefully we'll be able to do a recorded session of this. First off, I guess, are there any questions? Probably among other things, I really can't see you guys very well. Hang on a sec. Okay, now I can see the screen a little better.
I actually have a question.
Shoots.
So for the project, is there still a flora part of the geographical section?
Yeah.
Okay.
Yeah. What we're going to be doing in the initial stage is actually collecting all the information in terms of existing plant species that are recorded for the area. There should be some information, and I haven't looked yet. And that's actually what the folks that take that on. The Corps of Engineers has a big project called the Hawai'i Watershed Project, which has caused a huge amount of controversy in the last year or so. For that, theoretically, they had to do an environmental assessment, or what we call an EA. That environmental assessment should have included a botanical survey. And the Hawai'i Watershed includes all the way back up Palolo Valley. There should be other, I think I've actually got it in the folder. There are other reports that have somewhat or something to do with Palolo. City and county did something back in the 80s or something like that. Those also should have some sort of discussion of botanical, even if it's just to say it's all, exotic species and nothing native is there. So I don't know what all's out there. I do know that no one's looked at it systematically. So that's why we're sort of taking that on. Having said that, when we were doing the clearing with St. Louis down where we're doing the planting down near the rifle range, one of the ladies who was one of the sort of cultural advisors pointed out that there's a yellow shrub / sort of weed looking thing that she insists is endemic. It's actually used for topodyne. I've never seen it before. I mean, you find it all the way all over down there at the rifle range. So I don't know what that is. So if she knows, then theoretically that should be in print somewhere. So we're basically starting from sort of ground zero. We're hoping that there's information out there, but the first thing we need to do is actually collate all the sources which should have talked about botanical resources and be able to say there's either, here's what's in print and this is what it is, or there's nothing in print. So that way when we go out in the field, hopefully in November or whatever, we actually have some idea of not only what to look for, but among other things, that would mean we'd have to do a complete inventory of every plant out there, which makes it right off the bat sort of a multi-year study. So it's the classic example of research. You have to go back and see what all your background material is. So if you're doing floral, you want to do floral, that's what you're doing. You're doing all the background research on, stream species. That sort of makes sense?
Yeah, thank you.
Okay. For some reason, you guys are coming on the microphone on my webcam, which is sort of bizarre. I don't know. I have no idea what's going on here. So please speak up if you have a question. I can sort of hear you, but are you guys hearing me like I'm about 5 miles away?
No, you're okay.
Oh, okay. Well, it seems to be one way then. If I get it fixed, I'm going to be bringing my laptop in Wednesday. This is not a viable solution. In fact, what I think I might do is since there's absolutely no one here in class, is I might actually move it back to the office, and then if people want to show up, I'll then move it back here, since I know that we can do this theoretically. Because this is just a little more clunky, I think. Okay, so with that. Okay, we're going to start segueing into the Big Island. It's a little bit ahead of schedule, but not really too much since the semester's all squashed. when you're looking at the different islands, so now we're going to be breaking into particular islands. Almost all the themes that we talked about since the start of the semester will apply, but they apply in sort of a different context and different sets of meanings on each of the islands or each of the island clusters, just because of the context or the location of the islands and their, their relationship both with traditional Hawaiian society and in contemporary world. The Big Island is probably one of the most interesting. I mean, you guys remember you saw that at the very beginning of the semester with that History Channel or whatever it was documentary on, the dangerous Hawaii or whatever the hell it's called. Let's take a look at this. Let me switch out of this one. Well, let's do this first. Come on, don't be silly. Give me crap. Hang on a second. This thing's giving me attitude. Okay, first when you're looking at the Big Island, I'm going to turn the other one of these off in a second. I'm getting bounce back glare on everything here. When you're looking at the Big Island, thing to remember with the Big Island is with the exception of Loi'i, which is the newest island, which is still underwater. The Big Island is the most recent. It's the youngest of the major Hawaiian islands. And it's still very much in the process of formation. It's not actually in the process of systemic shield development. Shield development's pretty much stopped. In fact, the Big Island is actually in the first phase of erosion. Having said that, in about maybe 350 to 500,000 years from now, it's going to look just like Maui. So the island's basically at the point where it's been built. There's still some residual activity, but the island's been formed, and now what you're getting is the activity of basically wind and water. Cutting back that landscape. And probably most importantly is because the island's so recent, it's not stabilized yet. Let's see if this will show up here. Oops. Whatever, it's not you doing. Let's see if I can. Here's sort of a high intensity color image of the islands. So here's the Big Island over here. You notice several things. One is that if you look at anything in green or blue is basically offshore. If you notice one of the interesting aspects of the offshore is you look at various islands and it's real sort of striking what you see. We'll get into this more later, but here's the Ko'olau, here's Oahu, here's the Ko'olau caldera, here's Kaneohe. This is what's left of the whole eastern side of that volcano. It sheared off of the island of Oahu, fell out this way, and it's splattered all the way out to here. East Maui has partially sheared off. There was a massive series of volcanic eruptions during Haleakala's formation, then a bunch of shearing off, and that's this big mess of stuff here. So the Hawaiian Islands traditionally are formed. They're highly unstable, sort of think of like loosely packed bricks. And then what happens is that collapses and material falls off. Probably the most spectacular, as we'll see later, would be Molokai. The Molokai caldera is actually right here. And it too shears off and basically half of the island disappears and spatters its way up to here. So what you get is the islands have this history of building themselves, but they build themselves to an unstable height and then they fall off. And you have to remember the reason very simply is the fact that Hawaiian volcanoes are like this. If you go to the classic sort of, Trivial Pursuit contest, Mauna Kea is the highest mountain in the world by far. Because you not only have the 20-something thousand feet that it goes up in the air from dry land, but you also have the roughly almost 10 to 12,000 feet that it goes before it actually hits sea bottom. So when you add the two of them together, I don't know how much, it's an incredible amount higher than, for example, Mount Everest. And that's true with all the Hawaiian Islands. And I mentioned a little bit when I was talking about the idea of the sea temperature conversion energy project, the OTEC project. You've got these near sheer vertical surfaces. And that makes it highly unstable because if there's nothing really holding the top part on, when it falls off, it just doesn't slip down a little bit, the bugger actually falls into the ocean. So you have to visualize, what you're talking about is when this part of the island of Oahu fell off, that filled a sea ocean that was over 2 miles deep, and it filled it to within a couple hundred feet of the surface. That's a lot of dirt. So when you're talking about Hawaiian Island collapse and Hawaiian Island formation, it's very much within this context of instability. And then what happens, of course, is once that's fallen off, then the remainder is stable because now the loose part has sort of shed itself from the rest of it. On the Big Island, is still in that process. On the Big Island has not sheared significantly. There's been some shear on the area around Waipio, for example. On the Big Island is all a shear, and that's this area here. So this part of the island fell off, and it made this mess out here. The west part of the island hasn't done any shear yet, and the Kilauea side really hasn't done much shear yet. So that's what's still sort of pending. Let's see if we can actually see this here. Dang, this came out dark. How come? Okay, I guess I gotta get a little closer here. Okay, that'll work. Okay, so here we see this, we're back in Google Earth. Here's the Big Island. The most unstable parts of the Big Island are the Kilauea side. You can actually see one of the rifts here. And here's the main rift called the Great Chasm or the Great Rift up here. It wasn't until the 1960s, the 70s that they started to realize instability. I don't think geologists are really into instability. Geologists usually think of the world as being sort of a stable, fairly normal place unless something unusual happens. And it wasn't until the late 20th century they started to embrace the idea that a lot of the planet's inherently unstable, that instability is actually norm. And the Big Island actually turned out to be one of the classic examples of that. And the weird thing is they had all sorts of data back, a million years ago before you guys were ever born. This isn't showing up where it will come. We did work down in here. Let's just do it this way. This area wasn't covered by lava then, but if you went down here to Baldwin Park, which was down here, you actually could see that a park which had been built in the 1960s, which had the whole, parking lot and, beach access and the whole 9 yards. All of a sudden there was a major earth tremor right after it was finished, actually. And that whole area dropped by about 3 meters. So this whole section of the Big Island actually dropped almost 9 or 10 feet in the space of about an hour. Now, no one was killed, but that, among other things, that beach park immediately was underwater. So you could drive up to the edge of where the park was, and you'd see the luas. Everything was buried to the roof. The parking meters and everything they were gone. The light poles, just the tops were sticking out. And this event had occurred in a very short period of time. When they started to look, they realized this whole section of the Big Island, the whole southeast and south coast, was moving up and down. It was like flopping. It was almost like a door opening and closing. And it had this huge movement range of up to about 5 or 6 meters. So if you would, 15 to almost 20 feet of going up and down, depending on what was happening further up here on the ridge. And they started to realize that the only way you could explain that was the realization that when you actually looked at this whole section of the island, was it basically this whole section here really wasn't attached to the rest of the Big Island. It was attached, but it really wasn't attached in a coherent way. It was sort of just hanging on. And that was a real striking moment sort of in geology, was the realization you'd have whole chunks of an island just sort of there. And the realization, of course, hit them pretty significantly, because you have to remember that we're talking about rock. So like concrete, rock has no plasticity. Rock doesn't stretch. Rock can't deform like rubber or something like that. When rock deforms, it cracks, and you get the cracks in. And they suddenly realized that this was actually a large portion of explaining what the rift zones were. So if you remember about a year and a half ago, or whatever it was, when the rift zone occurred up in here, and made a mess up in this area, like Leilani Estates, which got wiped. All that was basically in a pre-existing crack. Now you have to remember, these cracks start in the bottom and they work their way up. So the stress has to be down in the deep earth, at which point the lava or the magma then moves up through that now, basically broken point of the planet, and moves back and eventually hits the surface. So when you're looking at rift zones, what you're actually looking at is the deep stress fractures on the island. And the geologists, you have to remember, you're talking geologic time here. But the geologists they've actually mapped out, I'm sorry, if I find it, I'll send it to you as an announcement or something like that. But the geologists actually have a map of both the rifts and also the island collapses. So basically this whole southern section of the Big Island, from here all the way down through here, is not really attached to the rest of the island. It's sort of sitting next to it. But it's not really part of this integral structure anymore. And the second rift up here, which is even more spectacular, this is the Great Chasm, or the Great Crack. I've been in there twice, and that's pretty trippy when you suddenly realize you've got a crack that's about 50, 60 feet deep, which goes all the way from down here all the way up to basically just about here. And it's, it literally opens and closes. I've never been in it when it's done that, but I have been in a spot where it was open a year earlier, and then by the time we got there, it was only about 6 feet wide, whereas it had been 40 feet wide just a year earlier. So basically, this whole part of the island's doing this vis-a-vis the rest of the island, and that's just a matter of time. That's going to shear off, and that would be the first of these really big shears. Like I said, this part of the island's already sheared off. This chunk here all fell off about not very long ago, maybe 10, 15, 20,000 years ago. This just fell off. And of course, it would have been two things. One is you're going to have a massive earthquake when that happens, is that severs, because now the island weighs less. So you've just basically taken that mass off, so the whole island's going to bounce. Secondly, is you end up with these absolutely spectacular tsunamis that would hit the islands in very rapid form. This is why we have that every start of the month test. If you have a tsunami, if part of the island breaks off here, for example, you're going to get, I believe it's a 12-minute warning before anywhere from 20 to 60-foot tsunami would hit the island of Oahu. So these things have very short gestation periods. So by the time you hear the warning, figure out what it's saying, it's about time to grab your rubber ducky or your stand-up paddleboard and just head for the high ground. And that's one reason why they have those tests here every month. They've come to the realization that the Big Island in general is a very unstable piece of real estate. And there's fairly significant parts that, if they came off, would make for a major mess. If this part of the Big Island were to shear off, you're probably talking about a tsunami. It wouldn't maybe hit Oahu. It's always hard to figure out where these things actually radiate out, but it would certainly head to the west coast, and probably in the range of 45 to 80 feet. It would take, I don't know, probably 6 or 10 hours for it to get there, because it's a pulse of energy. It's not actually water moving. So you'd have warning, but nonetheless, the size of these things is completely off the charts with this, like the Fukushima tsunami and stuff like that. So the Big Island is one of the more inherently unstable pieces of real estate in this part of the world, actually. The only one that beats us out is all the incredibly unstable explosive volcanoes in Indonesia, for example, are just time bombs waiting for a day to go off. The other thing you have with the Big Island, not surprisingly, since people are most familiar with that, is the fact that you actually have a series of highly active volcanoes. If you remember, I was talking about that, I think, a week or two ago. This actually very early on became one of the main attractions to the Hawaiian Islands, was people wanting to be able to go somewhere and see a volcano doing something. In most of the planets, you can stand on the volcano, and 99% of the time it doesn't do something until all of a sudden you're not paying attention, the bugger blows up on you. Here in Hawaii, what you have is because of the fact that it's deep material, it's got a magma pool underneath it, and they're shield volcanoes. They tend to have very sort of persistent patterns of eruption. In fact, it's almost more like oozing than eruptions per se. And Kilauea is the classic example of that. That and Mauna Loa have been erupting pretty continuously. I think Kilauea has been continuous since 1960, something like that. So it's been basically for like 50, 60 years, it's been an active volcano, in the sense that you can go up there and see it doing something, either there or on the rift zones. So you actually have 3 volcanoes in the Big Island. 2 of them are very famous. The third one gets no credit whatsoever, and I don't know why. This is the third volcano. The third volcano is Hualalai. This is actually one of the more active of the volcanoes, more so than Mauna Kea. Hualalai has generated enormous amounts of lava flows. The lava flows you see all through this area are all largely generated by Hualalai. If you go to Kailua Kona town, the lava flows that you see upslope and actually towards the harbor, that's all Hualalai eruptions from the either late 1700s or the last one was, I believe, 1840 or something like that. I don't remember exactly when. Very, very active volcano. It's been quiet the last 100-something years. It probably doesn't get a lot of creds for the simple reason that it's not a real, it just doesn't, it has had a history of being almost like, as we'll see later, Halakala. It has a whole series of sort of disconnected vents that basically are the main sort of caldera. So the main caldera is actually this whole thing, but it keeps on filling itself up with secondary eruptions and then blowing itself back apart and oozing material out. But it's, again, very, very active. And you can see here, if you actually look at it, there's no doubt you're looking at a major rift zone. You can just see the lines of the fissures and the lines of material coming off here, radiating in very different directions. So Hualalai is actually one of the more interesting things, not so much because of what it is. It's a very typical Hawaiian volcanic system. It's basically Kilauea's twin in many ways. What's really interesting, however, is the perception of Hualalai, the perception of this type of event, I guess, for lack of a better term. The Big Island is, well, I should say was till the 1970s, pretty much off the tourism chart. The Big Island was still largely in ranches, Parker Ranch, for example, and stuff like that. There wasn't a lot of economic activity on the Big Island. It was pretty much off the end of the planet, even more so than Kauai, actually. And then all of a sudden you start to get, as I mentioned earlier, you have the Rockefellers building their resort up here. And you have these ideas sort of mimic or, copycat resorts popping up all the way down here. Because there was the realization that if you could figure out, once they realized the Mauna Kea worked, that you can actually build a resort in a lava flow and make it attractive to tourists. Then there was a realization that 1, you had a huge amount of lava flows here. 2, you didn't have a lot of population. There were very few people living on this side of the island. And so what that meant, it was very cheap to buy real estate. So for a relatively smaller risk, you could buy a piece of real estate that had a beach frontage. You didn't have a large local population that was going to contest the beach frontage, so you could pretty much, like in the case of the Mauna Kea, make it pretty much private beach, which is technically illegal in Hawaii, but if you don't, if you build where there isn't anyone living, it's sort of private by default. And so what happened was, as you started to get what eventually became called by the 1990s, this section of the Big Island, which is called the Gold Coast. The vast majority of very, very, very super expensive high-end resorts are actually on the Big Island. They're really uber exclusive ones, like the name of them always escapes me. It's just right actually near the airport. That Kukio place that we looked at Friday, I think it was. All these are very representative of the Big Island, because the Big Island had enough space. You could actually make a resort that specialized in exclusivity. You couldn't do that on Maui or the other islands because there were just too many people and the area was too small. So what you got was by the 1990s, we'll say, is not only did you have this whole area become the center for massive resort development all the way from Keauhou on up, but you also had a massive increase in sort of the population living, both to service these resorts and also provide, you know, amenities and things for people to do if they weren't on the resort. And that's why Kailua Kona town grew up from a pretty funky little almost village to a very pricey and very, you know, sort of high-end place to live. And that included almost all this area. So you had literally billions and billions and billions of dollars invested in this whole region. And one thing that they realized very quickly you didn't want to have if someone's buying, what was that property we looked at Kokio was what, 8 million or something like that? If someone's buying an $8 million piece of fresh bare lava, what you don't want to remind them of the fact is the same volcano that put that lava down, and the Kokio lava would be from probably 1740, which in geologic time is like a microsecond. And Hualalai will erupt. It's actually expanding right now. So it's going to erupt again very, very soon. And it tends to spill out material down in here. So last thing that someone who just dropped $8 million in property wants to know is that the fact they've got an active volcano that's going to dump another load of lava on their property. That's one reason why it's so cheap to live in Puna. That's why so many people lived in places like Forest Gardens or whatever the hell that, Orchid Estates is the one I'm familiar with. But all those properties over in Puna that got swallowed up by the last rift eruption, because that land's super cheap. You can still buy property in Puna for, I don't know, probably 60, 80,000 acre, you know, $80,000 for a quarter or a half acre, simply because it's on an obvious, highly publicized lava flow, and people realize the property might not be around next year. This side of the island is actually just as unstable or temperamental, but there's so much money invested there, you don't want to bring that up. So Hualalai is sort of, by virtue of pressure from realtors, state and county governments and stuff, Hualalai has sort of been forgotten. It almost never gets discussed. People talk about 3 volcanoes in the Big Island. They're talking about Mauna Kea, Mauna Loa, and Kilauea. But there's actually 4, because Hualalai is actually more active than Mauna Kea by far. And it's actually as active as Mauna Loa. So it becomes one of those issues that, because of perception of the value of real estate on the lease side of the island, you sort of try to, you know, it's like the little kids where you hide, you know, you can't see me because I can't see you. Hualalai has become the invisible volcano in all the Hawaiian Islands. And it's a fascinating example of sort of shared perceptual wishful thinking, that you don't have a reality there. And this is why if you actually go and you look, and if you look at the USGS maps, for example, you'll actually see they actually have the lava flows dated. And you realize that this entire area is within the last 300 years. The Kailua Kona Airport is a 1705 lava flow or something like that. So this whole area has just basically been covered in sheets of lava from this volcano. Very, very active. She's been suspiciously quiet since the mid-late 1800s. And that's a huge worry if you're a geologist. They don't have the same level of monitoring as they do of Kilauea, simply because, again, there was just a concern that you didn't want to monitor this too much because you might get people worried about the investment they made in their property. So it's sort of really intriguing. It's going to be really interesting to see when Hualalai pops off, because you're going to have a ton of people running around in absolute panic. And I'm sure there's going to be a blame game right after that about, you know, how come we didn't know about this? How come we weren't told? Well, to be honest, they were told. It's just everyone downplayed it. Oh, yeah. Hualalai, yeah, it erupted in 1870, but it's quiet right now, which doesn't mean anything in Hawaii. So you've got 2 highly active units here and the other one over here. You've got your 3rd active unit, which is Mauna Loa. That's actually erupted in a series of rifts down here, especially down here around Milili. You can see all this area here that's been coated very, very recently. So again, what you've got is you know, sort of what you might call supplemental post-initial development. And if you just look at the Big Island, you can just see it's just lava flow after lava flow and sort of numbing repetition. And everything you see here is less than 250 years old, because anything older than that's turned into this material in between. So the Big Island's still sort of in the process of final formation, but at the same time, you have these highly unstable land masses. Come on, babies, we're not working here. On this side, which are getting ready to shear off. And that's going to lead you yet another problematic situation, which is, you know, what happens in terms of eruptive patterns if you suddenly lose this cap rock on this section, because you still got a large amount of volcanic material in here that, you know, would almost undoubtedly, you know, immediately come blowing to the surface. So you'd sort of end up with 2 things. One, end up with a massive landslip That's usually what they call these massive landslides, where you actually lose chunks of the planet. So when that shears off, then you're also going to have a very large series of subsequent eruptive sequences as the island tries to restabilize itself. So, I mean, that might occur this afternoon. It might occur 5,000 years from now. It might occur 10 or 20,000 years from now. You don't know. Geologists have no way of predicting this type of event. It's rare enough, and the islands are so young that it's impossible to predict it. But geologically, the Big Island is very, very unstable. And it's still in the process, partially of formation, but also you might say of deconstruction. And that sort of makes it, from that standpoint, it's a fascinating piece of real estate to watch, just because of the paradoxes of what makes it up. Wait, what happened here? One of the other side effects of the Big Island being so young, is you end up with what we call an undissected landscape. A lot of the Big Island, because it's getting constant lava flows coming over it, hasn't really gotten to the point where it's started to end up with erosion cutting streams and end up with cliff sides and such like that. And that's why you have very few rivers on the Big Island, despite the size of the island. And that's because most of your landscape really hasn't had time to sort of stabilize into stream flow patterns. Also, a lot of the material on the Big Island, as with all the islands, tends to be very absorbent of water. So if you're ever in Hilo, for example, you can be up in the back of Hilo town. You get up with a classic 10 o'clock in the morning downpour that's maybe a half an inch in less than half an hour. And there'll be water sheeting down the road, and 5 minutes later when it stopped, there's no water visible anywhere. The porous volcanic material that a lot of the Big Island is made up of, at least on the surface, the water just disappears into it. Now this makes for a huge problem if you're a farmer, because among other things, if you don't have streams, you can't do irrigation. So unlike the other islands, like say here at Palolo, where it's a much older island, the light material is all washed away. The material you have left is much more resistant to absorption. So you actually have dirt, you have mud, and you have rocks and stuff like that. In the Big Island and then the stream, in the Big Island you don't have that. What you have is springs, because most of the water hits down, it disappears into the rock formations, and it comes out at a point of weakness somewhere downslope. And this makes a lot of the traditional wet farming, the lowy type farming that we see in the other islands, this makes it really problematic for most of the Big Island. This is one reason why the Big Island really wasn't a power player in the Hawaiian system pre-European period until they figured out how to do dryland farming. Because dryland farming doesn't require streams or springs. Dryland farming requires mist. So when they came up with that invention of that particular type of agriculture, then all of a sudden this enormous amount of real estate that makes up the Big Island now became agriculturally food productive. And that was the huge shift in power of the Hawaiian Islands in the 15, 16, 1700s, was the movement of the Big Island from a period probably largely of sort of unimportance to suddenly finding itself as one of the big players in the island system by virtue of having a large population growth. But the Big Island still today has very little, except for places like Waipio. There's almost no wet fields. So what that also meant is, ironically, because you didn't have a lot of surface dissection, it made it actually very difficult in the sugar period. If you were going to grow sugar and such like that, the Big Island wasn't the best island because, again, you want controlled water. So most of the Big Island, with the exception of Kohala, really couldn't grow sugar effectively. The sugar would grow, but you couldn't grow it commercially because you were entirely dependent upon rainwater, and then that just that doesn't work commercially. Commercially, you need to have water when you want it. So the Big Island, pretty much by virtue of its landscape, by virtue of the volcanic systems, really was pretty much disappears. It disappeared, really wasn't visible until maybe the 1600s when dryland ag comes in, the huge field systems. It disappears again in the 1830s, 1840s, when the monarchy moves further west, and you get sort of the general depopulation of the island. So among other things, the dryland field systems collapse, which means, again, your population just disappears on the Kona side of the Big Island. So at that point, the Big Island pretty much sort of drops back off the charts. And this is why you have the huge ranches on the Big Island right into the 1950s and 60s, is in many ways sort of your dominant economic factor on the Big Island. Whereas on the other islands, there's ranches. Every island has ranches, but they're never the big players economically. It's always sugar. It's always some sort of commercial agriculture, sugar, pineapple, whatever. The Big Island, that just doesn't happen. So the Big Island sort of goes from not very important to hugely important during the Kamehameha period, being sort of the height of that. After his death, as the population and the systems of agriculture change, drops back off again, and really doesn't pick up until the 70s and 80s, when you get sort of the resurgence of new tourism-based economic systems on the Big Island. Among other things, what this means is the Big Island's incredibly vulnerable to tourism fluctuation. I have no idea what the unemployment rate on the Big Island right now is, but on the Kona side of the island, it must be about 50 or 60%. Because everyone over there works for a hotel or a resort, or works for some company who works for a company that does that. They're all either directly or indirectly tied to tourism. Other than coffee, like Kona coffee, you really don't have a fairly labor-intensive population. You still have ranches, but the ranches are very few and far between, and ranches require very, very well-trained, very specific individuals. And even a large ranch will only have maybe 30 or 50 panayolos. So you're not going to be able to suddenly handle like 150, 200 ex-hotel workers are out of work. They don't know what they're doing with cows. So what you've got is the vast majority of the population is entirely dependent on tourism. There aren't economic, or I should say agriculture, or other alternatives that they can use. And this makes the Big Island, I'm not sure if it's the most vulnerable. Maui's probably a close second, but Maui has more alternatives that they could do if they wanted. Big Island really doesn't. And if tourism were for some reason to stop for another 5 or 10 years, I suspect the Big Island would once again sort of disappear as sort of an economic backdrop to the Hawaiian Islands, despite the fact that it's being the largest by large part. One of the sort of interesting little things about the Big Island sort of fits in the Trivial Pursuit part is if you ever watch the evening weather reports, you'll notice the weather reports for the Big Island are significantly different. The Big Island, by virtue of its size, falls right into the bottom edge of a place that has what we call continental climate. The other islands are basically so small that they're entirely at the mercy of the ocean. Whatever climate, whatever weather patterns are occurring in the ocean, that's what hits the land. The Big Island is large enough that to a certain extent it actually generates its own weather. The combination of Mauna Loa, Mauna Kea, and that huge shield volcano system of the two of them tied together means that the Big Island actually to a certain extent generates its own patterns of rain, its own patterns of wind. And this is for another reason. This is one of the reasons why Hilo gets the rain all the time. That's actually by virtue of the continental climate, the fact that you've got a large enough landmass to generate climate versus the other islands, which aren't. The other islands are like boats in the ocean. Okay, that's about all I wanted to cover in this one. I want to keep this short because I got to figure out whether I was able to save this or not. So this class is going to be a little early simply because I want to see if I can actually find out what happened to the stuff that supposedly is being recorded. So I guess, are there any questions?